now let us incorporate these cleaning ranges. So, what I am trying to do here is from the cars data, I am accessing year of registration, I am putting a bound on it. The upper bound for year of registration is 2018 and the lower bound is 1950, both ranges inclusive. So, from cars I have accessed year of registration. Now, earlier I have used square braces, this is the other way of accessing it. This is also fine, or if you are comfortable with the other way of accessing, then that is also fine. So, next is price. The lower bound for price is 100 and the upper bound for price is 1,50,000, and similarly for power PS the lower bound is 10 and the upper bound is 500. So, if you see here, we started with around 49,531 after removing duplicates, and now let us see how many records are we losing after this. So, we are roughly losing about 6,700 records here. So, all these changes have been affected into cars. Also with year of registration it is hard to find out what is the age of the car. So, what we are going to do is we are going to subtract the year of registration from 2018 and add the month of registration. So, the month of registration we are going to divide it by 12, which gives you months in decimals, and I am going to create another variable called age that will contain the difference between the year 2018 and the year of registration. Now, that is the first step. So, I am going to subtract the year of registration from the year 2018 and then I am going to add the month of registration, which is month of registration by 12. So, let us start by doing this. So, first we are going to divide the month of registration by 12. So, let us just do that and see if the changes are reflected. So, whichever entries were 0 earlier in terms of integer, they become 0 with decimal. So, again when you add your year of registration, the difference between 2018 and the year of registration, when you add it with the month of registration, these entries will again be reflected as 0 under age. So, indirectly we are actually reducing the effect of 0, because if you try and use the month of registration as integer itself, it is going to create some problems, because 0 is not a valid integer to represent any of the month, and the months are being represented by numbers 1 to 12, right. So, because we wanted to get rid of the zeros, we are trying to divide each of the entries by 12, which means any entry which has a month of registration of 0 will automatically remain as 0, and that when you add it with the age, which is the difference between the year 2018 and the year of registration, and that will eventually go off, right. So, we are not letting go of observations which are marked as 0 under month of registration. At the same time, we are also making sure that it does not affect our analysis. So, we have converted the month of registration as decimal. So, I have just divided by 12. Now, I am going to create a new variable called age in line 125, and it is the difference between the year 2018 minus the year of registration for that particular record, and I am adding the month of registration here. You will see that an extra column gets added to cars, and here you will see the different values of age. Because we have added the months here, you will see values which are in decimals. So, we are going to round off the decimal places to 2 using the round function. So, the input to the round function is the column that you want to round off, and to how many places do you want to round it off to, and I am effecting these changes in the same column itself. So, again let us just open and see. Yes. So, all these values have been rounded off to 2 decimal places. So, let us just quickly do a dot describe. So, you will see that the count is again 42,772, and the mean age or the average of age is 14.87 with a standard deviation of 7, and minimum is 0, maximum is 67, and the median lies at 14.83. So, the mean and the median are not very far off. The mean is at 14.87 and the median is at 14.83. So, we know the data is not very skewed. So, now that we have incorporated the information of year of registration and month of registration into 8, we can drop off these columns because adding them is only going to make it very redundant. So, I am going to use the cars.drop function to clear. So, I am going to use the cars.drop function to drop them, and I am giving the column names as a list, and I am giving axis is equal to 1 because these are columns. Now, once you drop them, you can see that the number of columns have reduced by 2 and the year and month of registration have disappeared, right. So, now let us start by visualizing parameters. I am going to first start with visualizing age. So, let us see how does the histogram look for age. So, if you look at age here, you can see a slightly skewed distribution. It is not extremely skewed. Let me just drag the box to show you how does the distribution look. Again, you can fit a density curve over it. So, now again let us plot a box plot here for age. Now, we can see a clear cut box here, though above the whiskers there are a few extreme values or outliers, right, but even this was not possible in the earlier case. So, let us now look at the histogram for price. Now, for price here you will see histogram, even this was not seen earlier, but now we are able to see a few more ranges. And if you plot the box plot for the variable price, you will see a small box here. Earlier what we could really see was just a line, right. Now, this is better, but again you still have a few extreme values outside the whiskers. If you look at power PS, you will see that the histogram is now better than earlier, definitely, because earlier it was all bundled up to one side, and you can see that the density curve is also being fit here, and you will see more ranges to power PS than it was earlier. So, now that we have seen the individual distributions and we have seen the individual histograms and box plot for the 3 variables, let us see what their effect is on price. So, let us start by plotting. Age versus price here. I am using the rect plot that is under Seaborn package again here. So, let me just drag this output window to the left to show you how does the plot look. So, you can see that it is a scatter plot, and so you can see that it is a scatter plot. Earlier when you tried to plot year of registration versus price, you would have seen that all these values were bunched up together in one end, and we could not really see a clear cut effect of age on price, but here it is much better. We can see that cars which are priced higher are fairly newer. So, you have age on the x axis, price on the y axis, and cars which are priced higher are fairly new, but there are cars which are priced a little higher and are still older. So, we can treat them as vintage, and on a very general note, with increase in age the price also drops, right. So, this is the effect of age on price. Yes, it does affect a price to a great deal, but now let us see the effect of power PS versus price. So, I am again using the same plot to plot power PS with price. My power is on the x axis and my price is again on the y axis. So, here we can see with increase in power the price increases, and that is very clear from this plot, because earlier we were not able to infer the effect of power PS on price, we were not sure, but now that we have arrived at a very narrow range of working values, we can see an effect of power PS on price. So, with increase in power PS, the price eventually increases. So, these were the effect of power PS, age on price. Of course, age is a combination of year of registration and month of registration. So, two variables have been incorporated into a single, in the form of a single variable. Now, having done this, we are also going to check what are the effect of other variables on price, right. But before that, we have to even narrow down if these variables, if these mostly the categorical variables, if they have enough, if there are enough categories or if there is enough count under each category for us to even retain them. So, you again have seller, offer type, then you have A/B test and vehicle type, gearbox, and there are many more categorical variables. So, now let us see what is the individual frequency count under each of these categories. So, I first taken seller, the variable seller, and if you look at the value count, you will see private is 42,771 and commercial is only 1. So, the seller variable has two categories, private and commercial, but one of the category has only one observation. So, we are going to drop it, and if you are interested from a proportion point of view, then you can clearly see that private almost accounts for 100% of the proportion. So, now that we have seen all this, we can clearly say that the variable seller is insignificant. So, we will also see how to remove it later on, but just let us identify all the variables which are insignificant and remove them together. So, the next variable is offer type. So, in your earlier data you would have seen two offer type, one is offer, the other is request, and in this case all the 42,770 records are of the type offer. So, we do not have any of the records under request. So, again this variable is again going to be insignificant. Now, moving further, let us look at the variable A/B test. So, under A/B test, if you do a value count, you can see there is an equal split between the categories test and control, right. And from a proportion point of view, 51%, roughly about 52% is under test and the remaining 48% is under control, right. So, this is more or less, it is a close cut, it is more or less equal, and that can also be seen from the bar graph here, right. It is cutting very closely both the categories. So, both the categories are cutting very closely. So, they are more or less equally distributed, but let us see their effect on price. But even from the box plot, it seems like the effect is more or less the same. So, there is nothing much you can tell whether between categories test and control, they seem to have the same median, or they seem to have the same median for price. So, there is nothing much that we can infer even from the box plot. Right. So, for every price value there is almost a 50-50 distribution. So, we can't really conclude anything from A/B test. So, we are going to treat it insignificant. The next is vehicle type, and if you do a value counts for them, you will see that the category topping the charts is limousine, followed by that you have small car and then station wagon, and then you have bus and cabrio, coupe and others, SUV and then others, right. So, for a very proportion based count, you can see that limousine is the highest with about 29%, and let us just try to understand the proportion or the frequency better. Okay, from the plot it is more easier to understand that limousine is contributing the most, and followed by that you have small car, station wagon and bus, right. So, this is the order. It is more easier to understand from the plot than from the proportion count, when under each variable you have several categories. Okay. So, let us just see its effect on price. So, I am plotting a box plot of vehicle type with price. I have just dragged the output window to show you how does the screen look. So, for different categories under vehicle type, you can see that there are different price ranges, right. So, it is all different, there is nothing constant about each category, and limousine again is very different from coupe or bus or station wagon. So, the price are different for different categories. So, yes, vehicle type does affect price, and we are going to retain it in our model. So, the next variable is gearbox. Let us look at the count for Gearbox. You have 32,582 records under manual and the remaining 9,396 under automatic, and these are the two categories that are available. And if you want a proportion based view, you can see that manual counts for about 78% roughly and automatic accounts for roughly about 22%, right. And again we can do a count plot for it, which will also show you that manual gearbox are the most frequent. And from your box plot, let us see if the gearbox has an effect on price, and yes it does, because manual is priced lower compared to automatic, right, and that is evident from the box plot itself. So, yes, gearbox does affect price and we are going to retain gearbox in our final model. The next is the variable model, which is the model of the car, and if you look at the frequency count, you can see that you have about 247 models, right, and of course we can't know the value count for all, but the model golf seems to be the most frequently occurring. So, moving further, we are going to look into the variable kilometer. Now, to check the value counts, I have sorted out the kilometers in the increasing order based on the index using the sort index function, and you can see that the kilometer, which is equal to 1,50,000, contributes the maximum, and in terms of proportion, if you see, it contributes to about roughly 64%. So, it is the most frequently occurring kilometer. So, most of the cars have a kilometer of 1,50,000, and let us see if its effect on price, and I am doing a box plot for it. So, you can see here that different kilometers affect the price in a very different sense, and kilometers. So, if cars that have travelled lower kilometers like 10,000 and 20,000 are going are being sold or quoted at least for a much higher price, but whereas cars which have gone up, whereas cars which have had travelled for a lot of kilometers, eventually their price drops, except for this one variable, except for this one case where the kilometer is at 5,000 and the median of the price is very less. So, this is the only outlier in terms of the behavior, but otherwise with increase in kilometer you will see that the price also decreases. So, eventually when the car has travelled more, you will see that there is more wear and tear and hence the price drops, right. So, this is the take home message for this variable. So, let us now look at the variable fuel type. So, we are going to retain kilometer, and now let us look at the variable fuel type, and if you do a value counts for it, you will see that petrol is topping with a frequency of over 26,500, followed by that you have diesel, and then you have LPG, and then you have CNG, hybrid, electro and others. They all contribute for very small fraction, and in terms of proportion, you will see petrol is leading with about 66%. Now, let us just understand this better in terms of a bar plot. On my right, you have the bar plot. So, you can see that here diesel, you can see here that petrol is contributing the maximum, followed by that you have diesel and then you have LPG, but we can't even see the bars for the others because they are very less, and the effect of and the count of petrol and diesel is actually smearing out the effect of others, which is obvious. So, now let us just try to understand if fuel type affects price. Now, definitely it does. So, definitely it affects price, and that is clear from the box plot, because different categories of fuel types has different price ranges, and that is very clear from the box plot itself. So, yes, we are going to retain fuel type in our modeling. Let us move on to the variable brand. So, if you do a frequency count, you will see a whole lot of brands here, but the one that is topping the chart is Volkswagen with about 9,134 occurrences, and followed by that you have BMW and Opel and Mercedes-Benz and so on and so forth, right. So, again if you do a count plot, you will see different ranges for it. This is how the count plot looks for all the brands, and to understand if brand would it definitely affect price, we are going for a box plot. It is very clear from the box plot that all the brands do have an effect, but we are not able to see so which of the boxes correspond to which brand. That is not evident from the box plot, but on an overall note we can see that different brands have different price ranges. So, the last variable that we are going to look into is not repaired or damaged. Now, since these are second hand cars, there is already some damage that has happened to these cars. Now, this variable will tell you whether has that damage been rectified or has that damage just been retained and not looked after, right. Now, if there are two levels to, so there are two categories to this variable, one is yes, the other is no. When you have yes, it means that the car was damaged, but the damage has not been rectified, and the second category says that no, the car was damaged, but the damage has been looked after, right. So, these are the two levels. So, let us look at the value counts for this. So, the category with no is 32,507 and the category yes is 3,988, but if you want to see their effect on price, you will have to do a box plot, which eventually tells you that cars where the damage has not been rectified are under the category yes and they have a lower price range. So, cars where the damage has not been looked after to are being sold or quoted for a lower price range compared to the cars where the damage has been rectified. So, there is a clear cut difference between the two categories and their effect on price, and hence we are going to retain the variable not repaired damaged, right. So, now I am going to just remove this insignificant variables here, which are seller, offer type and A/B test from the car. So, I am just collecting their names as a list and I am using the cars.drop function, and you can see that from 13 we are down to 10, and that is from the cars data frame. Right. So, before we go further, let us just make a copy of this data here. So, this is just to make sure that we do not end up losing the analysis that we have done till now. So, before we move further, let us look at the correlation between our numerical variables, and I am using dot select underscore d types, which will select a certain ranges of data based on the data type that we have, and for this under the exclude parameter I am excluding all variables which are of the type object. Once I do that, you can see that cars underscore select 1 gets displayed and we have 4 columns which are price, power, PS, kilometer and age, and I want to calculate the correlation between them. So, I am using the dot cor function for this and I am rounding off the correlation to 3 decimal places. So, you have the variables again on the x on the y axis, you have the same variables, it is a matrix, it is a correlation matrix, and from here it is little hard to interpret which of the variables have the highest correlation value. So, I have cars underscore select dot cor which returns the correlation, and I am from there I am doing a dot location function based on the price, right, and this just returns the price and the first column. So, all that returns is the first column, right, and I am just taking the absolute value of it and I am just sorting them in descending order. So, I want values after price, and you can see that this is the correlation, and power PS has the highest correlation which is about 0.575, followed by that you have kilometer at 0.44 and age is correlated to price with a value of 0.336, right. These values are not high except for power PS, which shows a reasonable correlation. This method was to only check if there is some if there is a heavy dependency of one of these variables or one of these numerical variables with price, and that was the only reason to check the correlation. So, except for probably power PS, the other two variables do not have a very heavy influence on price. Again, the value of the power PS, again the correlation value of power PS and price is less, but it is not too less, it is roughly about 0.57, and that is okay, but it is not very strongly correlated to price.